In this video, I'd like to talk about how to remember Green's theorem. So, first recall from our earlier video the curl of a two-dimensional vector field. So if F is the vector field with just components P and Q, we just sort of pretend that F is a three-dimensional vector field, just like have a P, comma, Q, comma, 0 for the last component. And we saw that the curl was 0, comma, 0, comma, this scalar right there. It's going to be nice to access this scalar using some notation. And actually this dot product will do it. So we'll take the dot product of this vector right here together with the standard vector pointing one unit in the z direction. So I just wrote out the two vectors, and if you do a dot product, well, you've got some 0 times 0 plus 0 times 0 plus 1 times this thing, so you just get that thing, right? And this is it. So you just get the scalar, and this scalar right here is called the k component of curl, and notation to actually grab this scalar would be the vector curl of f dot product with the k vector. So let's talk about Green's theorem in the plane. So starting with a two-dimensional vector field, so f is equal to p of xy comma q of xy. From an earlier video, we saw that the line integral of a vector field can actually be written as the line integral over scalar functions just with respect to coordinate axes. If f really is p, that's the same p there and the q there. So take a look at the earlier video for that equality. In section 16.4 in Stewart 7th edition anyway, this is the statement of Green's theorem that's given, and this part's not so bad to remember. It's really this thing which is kind of awful to remember. And the whole point is, instead of remembering this, what you see inside the set of parentheses right there was in fact the k component of curl that we saw earlier. So I say this is hard to remember, and you can replace what's in parentheses there with the curl of f dot k that we saw earlier.